Algebra with Miss Swartz. Today we are moving on with our functions unit. We're going to look at linear functions, and so our essential question that I have listed here is how can we determine whether a function is linear or nonlinear? So we're actually going to spend 2 days on this section, and what we want to accomplish today is just being able to tell the difference between a linear function and a nonlinear function. So it should be pretty simple today. We're going to start actually in your journal on page 64 and 65, but before we get started, we want to define what linear is and what maybe nonlinear is. So we want to know the difference between the two, and then we'll look at those explorations in your journal together. So on page 66, there's some area to take vocabulary notes, but if you want to do this in your notebook, that's fine as well. But here's the definition of a linear equation in two variables. Okay, pretty simple, but we're looking for this equation, okay? And you may be wondering what m and b mean, but an equation that can be written in the form y equals mx plus b. And it says here m and b are constants, meaning m and b could be any number. So I showed you a couple of these yesterday. Y equals 5x plus 2, okay? That would be a linear equation. We know that they are linear when they can be written like this. So they have a y value, an x value, and x is not raised to a different power, those types of things. We can put it in this form one way or another. Okay, a linear function, another definition that we can have, not as necessarily an equation, but a linear function is a function whose graph is a non-vertical line. Okay, so remember, vertical would look like this. So a non-vertical line, so something that looks like this, and the function has a constant rate of change, which we're going to talk a lot about today, a constant rate of change. So we're going to be seeing that in some different charts. So it says a nonlinear function is a graph that is not a line. So there's all types of graphs out there. We can have graphs that look like that. We could have graphs that look like this. We could have graphs that look like this, okay? And you're going to look at all these different graphs as you go through Algebra 1, Algebra 2. But right now we're looking at linear functions or linear graphs, and a nonlinear function is going to be a graph that is not a line. Okay, so the function does not have a constant rate of change. Again, we're going to talk about what is a constant rate of change here in just a second. So get these definitions written down because those are very important to help us know the difference between linear functions and nonlinear functions. All right, so back to page 64. This is on page 64 in your journal, so you don't have to necessarily copy this down all over in your notes. But it says copy and complete each table for the sequence of similar figures. So in parts A and B, use the rectangle shown. So we're going to use the rectangle here for this part. It says graph the data in each table, decide whether the pattern is linear or nonlinear, justify your conclusion. Okay? So we're looking at the perimeter for this one. So we want to complete the table here. Okay, it should be pretty simple to complete this table. It gives us our x value and then it tells us, okay, what the perimeter of this. So if x was here, we'd have x here and 2x here. And to figure out the perimeter, we would plug x in and then add all our sides, right? Okay, so if we plug x in for this first one, we'd have 1, 1, 2 times 1 is 2, 2 times 1 is 2, so 1 plus 2 is 3, plus 1 is 4, we'd get 6, okay? And then we would do the same thing as we continued on to fill these in, so we would get 12 here, okay, because we'd have 2 plus 2 is 4, and then 4 plus 4, 8, so 8 plus 4 is 12. And you could kind of work your way through and figure these all out by plugging them in, but I'm going to save us some time here and plug these in, okay? Then we are going to graph the data in the table. So if x is 1, the perimeter is 6, so I'm going to try to hit right around 6 there. Okay, if x is 2, the perimeter is 12. 3, 18. 4, 24, so do the best you can. 5, 30. Okay. It says decide whether each pattern is linear or nonlinear. So if we look at this, Remember, the definition of a linear function is a function whose graph is a non-vertical line. But it's a line, it's not vertical, so this would be a function. So I'm just giving you some examples. Now notice, here, if we look at this, every time our x goes up by 1, what happens to our perimeter? Okay, it increases by 6. That is a constant rate of change. That's what we were talking about earlier, our constant rate of change. So let's look at the area one, though. So this is still on page 64. Okay, now if you plug in the area, remember this is still x and this is still 2x, but in area we're just multiplying our length times our width. We're not adding them all. So we would have 1 times 2, which would give us 2. Here we would have 2 times 4, which would give us 8. And we would have 3 times 6, which would give us 18. And we'd have 4 times 8, which would give us 32. And then we would have 5 times 10, which would give us 50. Okay, so if we graph this, 1 is at 2, 2 is at 8, 3 is at 18, 4 is at 32, and 5 is at 50. Okay, so is this a line if we were to graph this? Does that look like a line? Not really. That looks more like a curve. Okay, and if we look at our numbers here, as x goes up by 1, do we have a constant rate of change happening with our area? No. This time it goes up by 4, this time it goes up by 10, this time it doubles. Okay, well, it doesn't quite double, but either way, we do not have a constant rate of change here, so this is non-linear. You can see that by the graph, and you can see that by the chart here. Okay, so you kind of have seen examples of both. So the rest of the video, really what we're doing is just deciding, based on graphs, based on charts, and based on an equation, if something is linear or non-linear. That's our only goal today. So let's look at these first two. It says, does the graph represent a linear or non-linear function? Graphs are the easiest one in my mind, because if you look at this, all you're looking for is a line that's not vertical. Okay, for A, do we have a line here? No, that's not a line, so that's obviously a non-linear function. And you could say your explanation could just be not a line. Okay, if you look at the base word of linear, right there, it says it in there, a line. Okay, if you're looking at B, this is totally a linear function because that is exactly what we're looking for, a line on the graph. Okay, so now we're going to look at charts. So we have to be able to tell it from a chart as well. Okay, remember, when we're looking for linear functions, we're looking for something that has a constant rate of change. So as x increases, y needs to have a constant rate of change that goes along with that. Now, each constant rate of change could look different because you could have a negative slope, which we'll talk about more later on, or you could have a positive slope. Okay, so each could look different, but it needs to be a constant rate of change. So as our x goes up by 3 here, what's happening to our y's? Let's take a look. As this increases by 3, this one goes down by 6. Okay, so that needs to be constant. As this goes up by 3, does this go down by 6? Yes, it does. As this goes up by 3, does this go down by 6? Yes. So we could say this is a linear function because it has a constant rate of change. Okay, so look at B. As this goes up by 2, do we have a constant rate of change down in our y? So as this goes up by 2, we increase by 7. As this goes up by 2, now we're increasing by 11. Okay, and as this goes up by 2, we're increasing by 15. Is there a constant rate of change there? No. So this is a non-linear because we do not have a constant rate of change. That would be your explanation. Okay, so go ahead and look at these two graphs on your own. Decide if these are linear or non-linear. You can write and explain why. And then go ahead and see if these two charts are linear or non-linear. You're looking for that constant rate of change here. So you're going to try those two on your own. And then the last thing we're going to look at is equations. Okay, So equations, remember, have to be in the form y equals mx plus b. Okay, so we want to make sure that that's what our equations look like. That's how we know if they're linear or nonlinear. So if we look at this first one, we have y equals x plus 9. Okay, so if we look at this, we're going to compare it. Y equals, that's good. And then we have an x. You may think, oh, well, we don't have an m. Well, remember, in front of that x is a 1. So this could be considered good still. And then plus b. Well, it looks like we're good. So in this case, this would be linear because this is in the form of y equals mx plus b. Okay, so look at 4. Now you may think, oh, this one's not going to be linear. Well, we have y equals, so we're good there. Now our m could just be considered 3/5 x. We just wrote it different. We have 3x over 5, but we could separate that out. So we have y equals this. So we're good there. You may think, oh, well, we're missing a b. Well, we could say plus 0. And we're good. So this would also be linear. Now 5 is our first one that we have to pause for a second. We have y equals, then we have our b in front here. No problem there. You could have it written the other way around. And you could also have a subtraction sign because it's just plus a negative. But when we look at our negative 2x squared, okay, we have an x squared term. Well, is that represented here in y equals mx plus b? No, it is not. So this would be considered nonlinear because it does not fit y equals mx plus b. Okay, so this is kind of our concept summary. So representation of functions, this is in your journal as well. Kind of gives you some words, it gives you equations, it gives you an input-output table, and graphing. Okay, we talked a lot about these functions yesterday and how those look. Now we're looking at specifically linear functions, so it's good to kind of remind us what a function is. Okay, a function has exactly one output for every input. Just a good reminder. So your homework, where you're just determining between linear and nonlinear, is in your textbook, okay? And I have this kind of written wrong in here, so it should be 5 through 14 all and 17 through 23 odd. So you can get started on that once you're done with the notes. Have a great day.